Welcome everybody to Digital Beats, where we discuss the latest in technology, news, and innovative trends in digital transformation. Today's discussion will be super interesting. We'll be talking about key technologies in next generation enterprise level databases. Let me introduce you to our guests. Dr. Feifei is Vice President at the Alibaba Group. He is the president of the Database Products Business Unit of Alibaba Cloud Intelligence. He is a multi-award-winning scientist, and he leads R&D on cloud-native database systems and products at Alibaba. Also joining us is Charlie Dai. He is the principal analyst serving enterprise architecture professionals at Forrester. He is a leading expert in cloud, big data, AI, IoT, blockchain, and many more. And Charlie is also an avid tech blogger with millions of readers worldwide. So Charlie, what impact do you think AI is having on the database market?
Yeah, thanks, Milo. And I do love what Feifei mentioned previously regarding from a database management to the data management, because that's exactly what Forrester has been researching in the past decade. From the data management perspective, it includes the data ingestion to the classification and the integration between the preparation and the transformation, processing, and to the data security. And today, the data management focus has been around how to discover the connected data, how to classify and categorize the sensitive data, how to identify those duplicates, how to orchestrate the data in between. And coming to the database and the data warehouse market, we have seen that the machine learning and artificial intelligence has been driving the next generation of the data management solutions. And it can power many of the configuration and administration tasks that manage the modern database and data warehouse. Feifei already mentioned a lot of scenarios there, like to do the query tuning, to do the configuration recommendation for your different contexts, how to do the optimization for a database towards different workloads, how to do the backup recovery for database automatically, and eventually how to do some upgrades on top of your database. And then it's about to interpret your resource requirements based on the data and workloads. That is something around the intelligence. You don't need to do it by yourself. They can analyze the data and workloads and then give you suggestions to do the optimization towards your requirements. And then it's about the auto detection during the operations. They can help you to identify what might be some of the slow queries, for example, as mentioned by Feifei, as well as to warn you about some of the actions you have to take towards those kind of scenarios. So this is all about as mentioned by Feifei, self-pilot, right, and autopilot, and to power, to interpret, to auto-detect, and help you manage your modern database.
Right. And Feifei, so what do you think are the benefits of artificial intelligence on database technologies?
Yeah, I think on top of what Charlie and I had been saying already, which is from orchestration and management of the database system point of view. And in short, I call that AI for DB, using AI to make the running and management of database system more efficient and more effective, like autopiloting of your database system or self-driving database systems. So that's one aspect of how database community on database systems will benefit from having AI technologies. There is another aspect, which is what I call DB for AI, database for AI. What do I mean by that is inside database systems, traditional database systems have been focusing on dealing with structured data, data that are well-defined with a normalized format, like a table or with a well-defined schema. But increasingly, we have seen applications are generating large amount of semi-structured or even unstructured data. For example, key value pairs, text documents, JSON record, even go all the way to image and even video data. And we need to be able to process those data as well and drive out values from those data. And that needs the help of machine learning and AI technologies, because you need to figure out, for example, to do feature extraction from those data, and then to be able to process SQL statements that contain both structured data queries and unstructured data analytics in one statement, in one workload. So this requires database systems to integrate AI and machine learning technologies so that you can analyze those unstructured and semi-structured data and drive value out of those data. I'll give you an example. For example, you have an image that you want to query for. For example, I want to query an image with a person wearing a blue shirt. That's obviously an unstructured query because you need to understand the object inside the image. But at the same time, suppose you have a population database, you also want to find those persons who are around 30 years old living in the city of Shanghai. And then you want to join the results of these two to find out, oh, those who are about 30 years old from Shanghai wearing a blue shirt. So this is a perfect example where you are connecting query results from an image and then from a population database. And why you want to do this? I don't know. For example, Taobao and Tmall, our e-commerce website, are trying to figure out customers in that age group, in that location, who are interested in buying blue shirts, so we can make better recommendation to those customers who are coming to our platform. So you need to run these heterogeneous queries in one place so that you can support both unstructured and structured data analytics in one place. And you need to use AI and machine learning technology to do this. And that's one example. The other example is increasingly we see the trend supporting what we call predictive analytics. Traditional analytics is all about analyzing existing pattern in data. For example, group by aggregation, find the top 10 most popular items on my platform, find most 10 most active users from my user database, and so on and so forth. That's all about finding existing patterns activated by your data. But it's all about history, right? What about making prediction for the future? For example, based on the existing data from your database and how users are coming to your platform, can you predict which 10 users will be the most popular user for your platform in the next 10 days? Mm-hmm. Or even better, which 10 users will most likely view content from this category and do this for each category and make a prediction for the next 10 days. Why you want to do this? Because then you want to direct your marketing campaign, your sales promotion targeted as those predictive results. And traditionally, this kind of prediction workloads are being executed outside the database systems, outside data management system. Oftentimes you write a script, Python script, or whatever, or you write a Spark workload, and you run it in a machine learning platform, train your data, get a prediction model going, and then get the results out. But then in that work pipeline, what you need to do is to take your data out from your data management database systems and load all your data into another place and do your training and prediction over there. And once you get the results, you write them back to your database. So it creates this very long data pipeline, and your data is being duplicated twice as well. So it's very expensive, very cumbersome. Compared to that, if I'm a user, I would rather do all this in one place. Can I write a simple SQL statement against your database so that I can do this predictive analytics? So that's where AI and machine learning will come into picture as well.
Thank you very much. Let me just actually one more question, Feifei, I think is really important for us to really understand is just what are the directions that Alibaba Cloud is exploring in this area? If you could just answer that pretty quickly, that could be very interesting to us.
So we are all about building the next generation enterprise level cloud native database systems. We do this from a customer business centric point of view. So we always look at what business workloads are looking for, what customer needs. Then we dive out from those observations and then change those to our technology and product design. So for example, we are building up our cloud native database system and integrating those with AI technology, machine learning technology, as we discussed. We are taking cloud native technologies and integrate those with distributed technologies so that you can enjoy the benefit of both, having an enterprise level cloud native distributed database. So you can do share nothing, scaling out, as well as share store, share everything, elasticity, and all that. And then we are looking at how we can have security and trustworthy support. That's another trend we will be discussing, so that you can have enterprise level support for security related issues and trustworthy related issues. And then lastly, it's all about data management and data intelligence. We want to make a one-stop solution for all your data management, data transaction, and data analytic needs with our cloud native database systems. So with that being said, we have been building cloud native relational database system, PolarDB, cloud native data warehouse, analytic DB, and cloud native multi-model database, Lindorm. And then building also the tools supporting those, for example, database management system, which is a platform that allows you to do DevOps, data management, data transmission, and data clean data integration, so that data can flow very easily and freely between different systems, so that form a unified data platform for all your data management needs. So in short, that's essentially what we have been working on, and it's all about driving data values out and deliver those to our customer and to our business users.
Thank you, Feifei and Charlie. Thank you very much for your time today. It's been a really great discussion. I just want to say one thing to the audience. Hey guys, don't forget to catch the next episode of Digital Beats, where we'll discuss more trends in the cloud.